Hello, and welcome to another episode of Around the Verse, our weekly look at Star Citizen's ongoing development. I'm Sandy Gardner.
And I'm Chris Roberts.
On today's show, we take a look at the systems we'll be using to render holograms and comms in real time.
Yeah, it's pretty cool, so can't wait to show you guys. But first, as many of you know, the team is very focused on completing our 3.0 update for the persistent universe. So 3.0 is a giant leap forward from what's currently available in-game, and thanks to the dev team's hard work, the majority of 3.0's new features are almost complete. And we've shifted into the final phase of the production process that focuses on feature and content integration, optimization, and bug fixing. Now, we're also expecting many new players or people who have been busy playing something else to come back in and log in and play 3.0. So we wanted to make sure the user experience is really good, so we've decided to spend more time polishing and optimizing than we have in recent releases. In addition, we're also aiming to introduce our new Delta patcher, so you will only need to download just the files that have changed for each subsequent patch, which means no more 30 gigabyte downloads. But of course, this will require some fine-tuning and a lot of testing to make sure it works as intended. Now, we know that 3.0 is a big release, and you're all eager to play, and we're excited for you to play too, and we can't wait to get it done, but we want to make sure that it's ready. So if you've read the list of caveats we gave when we first started sharing our internal unpadded schedules, our very first point was quality would always trump schedule, and the second and third points about task estimates being unpredictable due to the nature of developing something that hasn't been done before, and the difficulty of estimating bug fixing and polish time are also important to remember as we go forward with our schedules on finishing 3.0. So that's why we've seen the constant changes to production schedule over the past few weeks. As new issues or advancements cross our paths, we've worked hard to communicate those to you no matter how good or bad the news may be. By its very nature, game development can be an exhilarating and frustrating and unpredictable process. So if our 3.0 schedule wasn't that, then you wouldn't be getting the true development experience.
No, you wouldn't. For our new backers who may not know, with each of our major releases, we've done different things to help you track our progress. For the 0.8 patcher that launched Arena Commander and the 2.0 patch, which introduced the PU, we had our weekly development updates that listed current blockers and resolved bugs. And for the march to 3.0, we've been tracking the major tasks we're doing with our weekly production schedule reports.
So now that we've reached this latest stage in the process, we're planning to adjust the format of ATV to highlight exactly what we're working on to get 3.0 out the door. Now, as all our studios are working hard to get 3.0 out, we have decided to suspend the studio update portion of the show so as to not distract developers with providing footage of their work for the studio updates. And instead, starting next week, we'll be launching a new segment called Burn Down. With this segment, you'll be able to be a fly on the wall for some of our production meetings and hear directly from the developers and QA testers about the week's biggest bugs, blockers, and challenges that we've been battling. It will be another great way for you to follow 3.0's progress. The weekly production report on the website will also be adjusting its focus to match.
Alongside the new Burn Down segment, ATV will bring you a weekly deep dive into a feature we're working on for the game. That way, you'll still be getting the same great detail about what we have planned, alongside the most current information on exactly where we are on the path to releasing 3.0.
Yep, and then once 3.0 is out, we'll resume the normal ATV cadence with the weekly studio reports and all that lovely eye candy that you guys like to see every week.
Now, let's shift gears to focus on two systems we've recently got working together, the secondary viewport and render-to-texture system. When combined, these systems can do a wide variety of things, from dynamically creating comm calls from other locations to rendering holograms in real time.
Yeah, no, I'm pretty excited about the potential of this technology, as it's going to allow us to do some really cool things in Squadron 42 and Star Citizen, of which you'll see maybe a little hint of to come. Let's take a look.
We've been working with the graphics engineering team in the UK to develop and make use of their new secondary viewport tech, which in itself makes use of the new render-to-texture system. It allows us to do some really cool things for our in-universe narrative in both Squadron 42 and the PU. So far we have used it for comms calls and holographic volume rendering. And we have been syncing very closely with the engineers that write all the new rendering code to make this happen, and we're slowly homing in on a final feature set.
First of which is secondary viewports, which allows us to get a second view onto the world, or or many different views onto the world. This is built on top of some new tech we have called the render-to-texture system. Prior to the render-to-texture system, if we wanted to render some user interfaces or screens or visors, we would have to render them directly into the game world, and this happened after all of the rest of the scene had been rendered. What that meant is that the UI would always look on top of the game world. It would never truly fit in, and therefore it would never correctly be obscured by things like glass or fog or bloom in the same way as everything else in the scene. And this has always bothered our UI artists. So for the new system, the idea is we render all of this content into textures first, and then we use them textures in the actual main rendering pass of the scene and composite them in with whatever effects we need, like whether we need them to look holographic or like they're on glass or whatever it might be. And it lets them to bed themselves in the game world much better and have a much better lighting and sorting with the rest of the scene. We also get a few other benefits from this. We get better anti-aliasing, better sorting, we get better performance actually, with the fact that we can reuse the same screen on many different displays in the game world just by rendering it once. And we can even use the same screen on the next frame of the games to be able to avoid rendering cost. If, for example, you've got a screen which doesn't need to animate or doesn't animate very quickly. These new pieces of tech we've been using in many different systems. So we've got all of our UI screens and our visors, all of our holograms and video comms calls. And there'll be several other uses we're hoping to fit in further down the line, like things like mirrors, things that are typically really difficult to achieve in games.
The render-to-texture system starts at the engine level when we're gathering all the objects. Really, at this point, all we really need to know is that the objects are going to be streamed, so the streaming system needs to be informed, and we also need the max and min screen space size. We use the max and min screen space size along with the UV textile density to be able to calculate how much screen resolution is required for that texture. The minimum screen space size is required because that texture may be used on multiple different objects. As it's used on multiple different objects, we then need to get the largest size and use mip mapping down to the smallest size. When you have a screen within a screen, we need to know the ordering of the RTTs. So as one RTT is rendered before another, it can then be used as a texture within the second one. We also need to know that an RTT within an RTT within the main pass, if the first RTT is half res of its parent RTT, and that RTT is half res of the main pass, the first RTT must be a quarter of the res at rendering size. The rendering system has a fixed memory budget. To do this, we allocate one large texture ahead of time. This texture is called the texture pool, or in this case, the render texture pool. It's very similar to a standard shadow pool system. We recently rewrote our shadow pool packing system to be a power of 2 quad tree allocator. We use the same power of 2 quad tree allocator for the render text system. We render the textures as power of 2, so i.e. 128, 256, 512, 1K. We use the smallest size for that the texture needs that we can fit in. So if you need a render texture object at 800 by 800, we'd use a 1024 by 1024. And as you move closer and further away from the object, it will require a lower or higher resolution, and we progressively move up and down. One of the benefits of render texture is we can reuse those textures for multiple objects. So if you have a scene with many different billboards in them, let's say 12 billboards, we would render that texture for the billboard once and then reuse that texture over 12 different billboards. The original system, the UI system for instance, wouldn't do that. It would render the UI or that billboard 12 times. Because the render texture system is now a texture and it's not Flash just rendered into the world, it means we can render any curved screen, anything like that. The only downside to that was we had to implement a new system to manage the mouse pointer interactivity that we already had. We had to make some modifications to bring in a mouse pointer system which takes screen space size and remaps that into object UV coordinates, and then we can then pass that object UV coordinates to the UI system. The UI system is able to work out where on the object that mouse pointer is, and then in reference to where on the flash that is, and then therefore you can then start selecting things. With the character animation, it normally goes through the camera system to decide whether it needs to be animated, whether any of the facial animations need to be run. And as we were running this through the render texture, it wasn't in view of the main camera. What would happen is it just wouldn't render when it was in the render texture system. We resolved this by having the usual camera culling system and the facial animation system, stuff like that, communicating with the render texture manager. That render texture manager will allow it to go through all the different cameras and work out exactly how big it is on screen or how big it is inside our render texture manager. And it will allow it to decide on the level of detail of the facial animations and the level of detail in the character animations.
If you do pre-rendered comms, you can't really acknowledge characters changing costumes or ships or locations. So real-time rendering for us makes a big difference for immersion. Comms calls reflect what's going on in the verse, and for the persistent universe, it opens up customized player avatars calling each other, all rendered live. Another possibility are, for example, CCTV or other room view style puzzles, or live recording of views to be featured somewhere else in the verse. There are some remarkable consequences of these advances in the tech. Our capital ships feature big holographic volumes on bridges or in briefing rooms, and that means the player can walk around them freely. For those, we wanted to not just render a second viewport using 2D display screens, but actual 3D holograms, and you can view them from all angles.
Secondary viewport camera is updated dynamically to match the relative viewing angle from the main player's camera to the projection volume, and then as you move around, the secondary viewport camera moves, and therefore you can essentially move around the holographic projection. Using the existing rendering pipeline means that we can render essentially any object into the holographic projection, but there's no need for material duplicates or any duplicating of material setup. It just basically works with these existing shaders. So as well as the existing shaders, we also have developed dedicated shaders for various things. For example, like abstract user interface objects, or if in a mission briefing you wanted to go to a waypoint, the waypoint could be displayed as holographic, and it will be using one of the dedicated shaders that we developed. And the cool thing about this is that we can automatically fade the objects that are in the source volume as they get closer to the boundary of the volume. We can automatically fade them out so it doesn't clip as it goes through the boundary. We also exposed two new artistic features where we basically allow the objects to dissolve and tint independent of the material setup.
Being able to light these 2D and holo RTT presences in real time at a source location and then seeing the results in the corresponding 2D display screen or in the 3D holo target area immediately felt exciting to me. With this new tech, we can have a character calling another ship or location, and the call appears on either a 2D display screen or inside a 3D volume, with the calling partner essentially being telepresence then. What's really cool about the holocomms or telepresence is we can arbitrarily scale the source volume up or down and easily create larger-than-life representations of characters without having to resort to cheats like scaling up or anything of the scene. And this makes it possible to have something like a Grand Admiral appearing as a looming figure inside the Bengal carrier hologlobe versus him just being a small life-size presence. We also added the ability to tint or dissolve any object in our scenes at will, which helps staging something like mission briefings where waypoints would need to flash green or enemy presence is marked as red.
So this tech's progressed really, really fast, and we got some really great results, but there's more we want to do with it. Next thing for us is to optimize it further. We really want to make sure that there was no performance impact when you have these secondary renders or these holograms and such in the scene. We're doing a bunch of exciting things to try and combat the performance issues, such as if you're going to video call to someone and you can only see like a slight part of the background behind them, we'll use what we call the environment probe, which is normally used for reflections of the scene. We're going to render that directly behind the player to avoid having to render the entire background scene. And in most situations, you won't be able to actually tell the difference. So that's one of the examples of the optimizations we're going to be making, but there'll be many more to make sure that we can really use this tech in as many situations as possible so that you get to see the fun gameplay that will result from it.
So now that we have the basics of our holotech in place, we want to stabilize it more and spend more time finalizing the look of these holograms. That means all the good post-effects goodies you can think of, interlacing lines I want to have, flickering when there's poor signal quality or when the holographic display is damaged. Yeah, we can't wait to show you more of this when it comes to life later in the PU and of course in our Squadron 42 narrative. Thanks for watching.
Pretty awesome, eh? And for the eagle eye amongst you, you will have spotted the first appearance of Ben Mendelsohn's character in Squadron 42 and Liam Onion Knight Cunningham in the work in progress holo briefing test scene that we've been doing. Our graphics team have really created something I haven't seen in any other engine and allows us to actually do proper holographic telepresence. None of it's pre-rendered or faked, it's all live, and the possibilities for longer term gameplay are pretty exciting.
And that's all for today's episode. As always, thanks to all of our subscribers for making it possible for us to produce all of our video content. We've just announced that August ship of the month is the Apua Kartual, so that means subscribers can test out this Jan ship all month long. Just log into the game to take it out for a spin.
Yeah, and thanks to all our backers who have supported the game over the years. Opening up the development process to you all has been both challenging and extremely rewarding, and I would say the emphasis would be mostly on rewarding. So I can't thank you enough for making it all possible.
Finally, if you want to know what all of our offices did over the past month, then check out the July monthly report, which goes live tomorrow.
So until next week, we'll see you
Around the verse.
Thank you for watching. So if you want to keep up with the latest and greatest in the Star Citizen and Squadron 42's development, please follow us on our social media channels. See you soon.